Hello everyone, welcome to Extramarks live classes. In this session today, we are going to discuss about matter and states of matter. Basically, we are going to continue our discussion on states of matter. And what all we are going to study today, we will be discussing about liquid state of matter and gaseous state of matter in detail. In addition to liquid state and gaseous state, we will also talk about two newly discovered states of matter, that is the plasma state and Bose-Einstein condensate, which is abbreviated as BEC, Bose-Einstein condensate. Then we'll talk about various scales on which temperature can be measured, and we'll practice a few numerical questions on conversion of temperature from one scale to other scale. So let's begin the session and let's quickly revise about the solid state of matter, which we have already discussed. We know that matter in general can exist in these three states, that is the solid state, liquid state and gaseous state, where matter in solid state differ from its own liquid state and gaseous state in a few terms. Whenever we talk about characteristics of particles of any matter, there are two or three main properties which we talk about. The first is interparticle forces of attraction. Interparticle forces of attraction has got a lot to do with the state of matter. We'll understand how. The interparticle space which is available and the kinetic energy which is possessed by the particle in any state. If I talk about solid state, in solid state the particles are densely packed. That means the interparticle space is minimum. The particles are so closely packed that solids have rigidity, they are rigid, they have high density. But solids are rigid because of one more reason. The attractive forces holding the particles together are quite strong. If I compare the strength of attractive forces in these three states of matter, the strength of attractive forces in solid state is maximum. And the kinetic energy which is possessed by the particles in solid state is minimum. In all these reasons, all these are the reasons behind definite shape and definite volume of solids. So this was about the solids at molecular level, at particle level. What properties do they possess? How are the attractive forces? Are they strong or weak? What about the interparticle space? What about kinetic energy? So we have already discussed about the solid state of matter. Now let's talk about the liquid state and gaseous state in detail, and we'll keep comparing the liquid state and gaseous state to solid state to have more clarity. Okay, so beginning with the liquid state, how can we define or say give a statement about the liquid state? Liquid state is that form of the matter which possesses fluidity. When we were discussing about solid state, when we were discussing about solids, I told you that solid state is the state of matter which possesses rigidity, isn't it? So liquid state and solid state are differ from each other, where solids are rigid. They cannot change their shape. They are non-expandable. They are not incompressible. But liquids have fluidity. That means liquids can flow. But liquids are similar to solids in one case. Solids as well as liquids. That means any matter in solid state and liquid state is incompressible. We cannot compress a matter practically in solid state or in liquid state, and that is why these two are the reasons why liquids have a definite volume. They are not compressible, hence their volume remains fixed. But since they are fluid, their shape can change. When you fill liquid, or if I take example of water, water is a liquid, most common liquid, isn't it? So if I take example of liquids like water, it takes up the shape of the container in which you fill it. That means liquids have a definite volume, but since they are fluid, they have a capability to flow. Their shape is not fixed. They take the shape of the container in which we keep them. If you look at a liquid at molecular level, you will be able to see that the space in between the particles, all these pink circles are particles here. These pink circles are representing the particles in the liquid state, and you are able to see that the space, isn't it, is a little more as compared to the space that was present in solid state. Let me show you how particles are arranged inside the solid state so that you can compare. The particles in the solid state are closely packed, they are densely packed, and minimum possible space is left in between them. Have a look at the amount of space available here and the amount of space which is available here in between the particles. Obviously, the interparticle space is more in liquids, isn't it? And the interparticle space is quite less in case of solids. If you draw the particles here as well, they are densely packed, very less space is left in between the particles. So this is how liquids look from inside. If you get to see at the molecular level or say particle level, because particles can be molecules as well as atoms. So I am using the general word particles here. The particles are arranged like this. Let's talk a little more about the properties of the liquid state. So this we have already understood that they do not have a fixed shape, but they have a definite volume. They acquire the shape of the container in which they are kept, and particles of a liquid have comparatively more kinetic energy as compared to the particles in solid state. And this high amount of kinetic energy which is possessed by the particles in liquid state is responsible for fluidity. Actually, there are two things, there are two properties which play hand to hand simultaneously. They control the fluidity and rigidity. The first is amount of kinetic energy which is available with the particles and the strength of attractive forces existing in with the particles. If I talk about amount of kinetic energy as well as the amount or say strength of attractive forces present in between the particles of liquid, both are at the intermediate level. The attractive forces are weak as compared to the attractive forces in solids, and the kinetic energy is more. Hence, the liquids can flow. The particles in a liquid cannot leave each other. Okay, the particles in a liquid cannot leave each other, but they possess a little more kinetic energy, and hence they have a little more movement as compared to the particles in solid. They are not fixed at one place, but they remain connected to each other. If I talk about a few particles of liquid, they all remain connected to each other through interparticle forces of attraction. But they are not fixed at these positions. Their positions can change. If this particle will start moving in some direction, suppose this water from this side the particles on this side starts moving in one direction, all the other particles will follow. Why they are following? Why these particles are not able to leave other particles and move to some other place? Because the attractive forces are strong enough to hold them together, but the attractive forces are not strong to ground them at one place. So all the particles can move in group. That is why liquids flow. All the particles follow the particles which are moving in some direction. If, like you must have experienced, if we spill some water and we give it direction, all the water starts flowing in that direction, isn't it? We used to play like this with water when we were kids. We used to give direction to the water and all the water follows, isn't it? So this is why, this is the reason. The attractive forces are not strong enough to ground them at one position, but the attractive forces are strong enough to hold them together. So if one particle is moving in one side, all the others will follow because they are connected to each other. They are held together through some attractive forces. But yes, their positions are not fixed, and this is the reason why liquids can flow. They also, like liquids also possess a property of diffusion. What does this mean? This means that liquid allow other substances, be it in solid state, liquid state or gaseous state, to diffuse into itself. If I take example of water. Water is a liquid and I am taking two substances. First is potassium permanganate and other is ink. Potassium permanganate is solid, which is purple in color, and ink is liquid, which is blue in color. So water allows solids as well as liquids or gases to diffuse into itself. And same is the case with other liquids. How this becomes possible? Let's understand with the help of one example, some small activity. Suppose I take a small crystal of potassium permanganate. The formula for potassium permanganate is KMnO4. I take this small crystal of potassium permanganate and I drop it into water. This potassium permanganate is dark purple in color. As soon as I drop this crystal of potassium permanganate in water, what I observe? I observe that the crystal of KMnO4, potassium permanganate, starts disintegrating and the particles start spreading here and there, and after some time the whole water which was taken in the beaker acquires a purple color. The purple color of the KMnO4 is spread throughout the available water. How does this happen? This happens because the particles of potassium permanganate are able to occupy the interparticle space present in between the particles of water. So, if you look at this at molecular level, you will be able to see molecules of water. These large ones are the molecules of water, and the KMnO4, the potassium permanganate, its particles will acquire the interparticle space. So, diffusion in liquids is possible. It is possible for the other substances in solid, liquid or gaseous state to diffuse inside the liquid state because there is a space available for their diffusion. So, liquids allow. Similarly, if you take ink and you put 1 or 2 drops of ink in a beaker containing some amount of water, what will you observe? You will see that even if you do not stir it, the ink will slowly spread throughout the water and make all the water blue. So, this is the example of diffusion of liquid into liquid. I'm sorry. This ink is a liquid which is going into water, which is again a liquid. So, ink is diffusing into water. So, this is an example of diffusion of liquid in liquid, and here KMnO4, potassium permanganate, is diffusing into water. So, this is an example of a solid diffusing into liquid. Similarly, if you think of aquatic life, what do you think how aquatic plants and animals they breathe? Especially if I talk about aquatic animals, what do you think, from where do they get oxygen? We have studied, we have heard that aquatic animals utilize the oxygen which is dissolved in water. How oxygen gas dissolves in water? Oxygen gas actually diffuses into water, isn't it? So, when oxygen or any other gas dissolves in water, it is actually the diffusion of a gas in water that is taking place, isn't it? So, liquids allow solids, liquids and gases, other substances in solid, liquid and gaseous state to diffuse into it. Some examples we have taken, and I hope it is clear to everyone how this diffusion becomes possible and which property of liquids allow this diffusion to happen. The available interparticle space makes it possible for other substances to diffuse into any liquid. Okay, let's move ahead and let's again talk about the fluidity. Okay, we have, like I have made you understand this, but let's discuss once more that the forces of attraction between the particles of liquid are strong enough to hold them together, but due to the presence of greater spaces in between the particles of the liquid, the particles can run over each other. You must be thinking, why one particle or say a number of particles follow each other? While flowing, what happens? They slide over each other, and this becomes the flow possible. Here you can see water flowing through a pipe. Here you can see milk flowing out of the glass which is tilted. So, how this flow actually takes place? The reason you have understood intermediate amount of attractive forces as well as intermediate amount of kinetic energy which is possessed by the particles. But while a liquid flows, what happens? The particles, different layers, they slide over each other, and this is how liquid flows, and this is how they change their shape. So, liquids are able to change their shape because particles are not grounded at one place. They can run over each other, they can slide over each other, and they can flow. But yes, they remain together. Whatever they will do in group. If they are going in one direction, all the particles will go in that direction. So, this is how liquids flow. Okay. Again, coming on to the diffusion in liquids, we have just now understood that liquids allow other substances to diffuse into themselves. But the rate of diffusion, the speed at which diffusion takes place, varies from substance to substance. If I compare the speed at which diffusion of two different liquids takes place inside water, I will be able to realize that yes, a few liquids diffuse faster and a few of them diffuse at a slow rate. What is the reason behind it? Here is a diagram, here is an image which is showing the diffusion of ink into water. So, let's understand diffusion once more. As soon as the drop of ink goes into water, what happens? The particles of the ink starts diffusing. What we have understood about the diffusion? the definition, from the definition point of view, what do we say about diffusion? We say that diffusion is the movement of particles of any substance from a region of higher concentration to a region of lower concentration. So same thing is happening here. As soon as this drop of ink goes into water and it settles down at bottom, the particles of ink start moving from a region of higher concentration to all the regions where the concentration is less. Obviously, most of the particles of ink are here, and here the number of particles of ink are either 0 or very less. So particles move from a region of higher concentration to all the regions where concentration is low, and this is a passive process that we need not to do anything. Even if we do not stir it, what will happen? The ink will diffuse in all the directions, and after some time we'll be able to see that an even blue color is gained by the water. So this is how diffusion takes place, but the speed at which diffusion takes place, the rate at which diffusion takes place for different liquids is different. And why is this so? Because of the difference in viscosity of liquids. Yes, what is meant by viscosity? The degree of thickness. Viscosity directly gives us an idea about thickness of any liquid. If I take example of honey and ink, okay, in first case what I'm taking honey, and in second case what I'm taking ink. In glass A I am putting few drops of ink, and in glass B I am putting a few drops of ink. What will happen? Think of it yourself. You can do this small activity at your home. You can take a small quantity of water in 2 transparent glasses and put 2 drops of ink in one and 2 drops of honey in one. Okay, what will happen? You will be able to see that ink diffuses at a very faster rate, but honey takes a lot of time to mix with water, because honey is thick and ink is thin. That means honey is more viscous as compared to ink. So viscosity is inversely proportional to the rate of diffusion. Okay, viscosity means the thickness. It is the measure of thickness of any liquid. Higher the thickness, lesser will be the speed at which diffusion of that liquid will take place. So rate of diffusion varies from liquids to liquids, and it totally depends on the viscosity of the liquid. Okay, now let's move to the gaseous state of matter. Gaseous state of matter is the state which neither possesses definite shape nor it possesses definite volume. Yes, any substance in its gaseous shape neither has a gaseous state, neither has a definite shape nor has a definite volume. That means the particles are free to move. They are fluid. Gaseous state is also fluid. They are highly compressible. We can compress the same quantity of gas in a very small volume, and we can allow it to expand to enormous volumes like 2, 3, 4 times of the volume previously it was kept at. That means gases are highly compressible, as well as gases show enormous expansion. So they can expand, they can be compressed. That means if we take a small quantity of gas and we keep transferring it to different vessels having different volumes. Suppose I have 3 containers here. The first one is of 50 ml quantity, other one is 100 ml quantity, and the next one is 150 ml quantity. And I am taking the same amount of gas and putting them in 3 different containers. When I put the same amount of gas in first container, its volume will be 50 ml. When I transfer the same quantity of gas to the second container, it will occupy a volume of 100 ml. And when the same quantity of gas is transferred to third container, it will occupy the volume, it will occupy 150 ml volume. What does this indicate? This tells us that the volume of a gas is equal to the volume of the container in which it is kept. If you fill it in a smaller container, its volume will be less, and if you transfer the same gas, same amount of gas to a bigger container, its volume will increase. So this is a point to remember, that volume of a gas is equal to the volume of the container in which it is kept. And if I talk about the shape of the gas, gaseous state do not have a definite shape. It will take up the shape of the container in which it is kept. Okay, so it fills up the container completely. It will occupy all the volume available, as well as the shape of the gaseous state will be same as the shape of the container. Let's move ahead and talk a little more, discuss a little more about the gaseous state of matter. As I told you, any substance in its gaseous state is highly compressible. Now the question is, what makes this compression possible? First of all, we need to understand what happens when we compress anything. When we compress a substance, its particles come close to each other. Now imagine about solid state. There was very less space available in between the particles of solid. Sometimes we say that the negligible space is available. So if we want to compress a solid, we need to bring its particles a little more close to each other. So if two particles have to come close to each other, there should be some space available for them to move. But in solid state, the space is not available, and in liquid state also, the space available is not practically sufficient for the compression. But in gaseous state, what happens? The large amount of space present in between the particles make it possible for the particles of gas to come close when we apply high pressure on them. So, if I even talk in terms of interparticle space and interparticle forces of attraction in the gaseous state, the interparticle space is maximum and the interparticle forces of attraction is minimum in the gaseous state. Okay. So, and particles possess maximum kinetic energy. If we compare the kinetic energy possessed by particles in gaseous state as compared to the kinetic energy possessed by particles in liquid and solid state, we find that we are able to realize that the particles in a gas possess maximum amount of kinetic energy, and hence they show continuous random motion. They are in a state of continuous motion, and that is the reason why they can expand, they can occupy all the volume available in the container in which they are kept. And the available space in between the particles make it possible for the gas to be compressed. Okay, so spaces in between the particles is very large as compared to solids and liquids. And as I told you, gases again have fluidity, and the degree of fluidity is very, very high as compared to the fluidity in liquids. The particles in the gases are not bound to each other. They are neither bounded at one place, they are neither bound to each other. Each and every particle in a gas is free to move in any direction. Okay, so gases can flow easily because of negligible amount of interparticle force of attraction acting in between the particles and very large space available in between the particles. Gases also show property of diffusion. Gases can diffuse into each other. If you bring two gases in contact with each other, particles of one gas will diffuse into other and the particles of other gas will diffuse into the first one. So this is how we can explain diffusion in one more way. You can also define diffusion as intermixing of particles of two substances when brought in contact with each other. The particles of two substances, they intermix. This is also known as diffusion. So gases can diffuse into each other. Gases can also diffuse into liquids. For example, oxygen gas diffuse into water and is available for the aquatic animals to breathe. So this is how diffusion of two gases will take place. If you will bring two gases in contact with each other, particles of one gas will move towards the other side, the particles of other gas will move towards the first side and they will intermix, and this process of mixing will continue until the concentration is equal on both the sides. So yes, when we bring two gases in contact with each other, they intermix, and this is known as diffusion of gases into each other. Now coming on to the pressure of a gas. What is meant by pressure of a gas? This is not the external pressure that we apply on the gas. I am right now talking about the pressure which is exerted by the gas on the walls of the container in which it is kept. Yes, each and every gas continuously exerts some pressure on the walls of the container in which it is stored, in which it is kept, and this happens because of constant random motion of particles of a gas. We know that the particles of a gas in a state of constant motion, continuously they are moving, and while these particles are constantly moving, what happens? They colloid with each other. They colloid with each other as well as they colloid with the walls of the container, isn't it? If you observe a few particles, I am going to highlight. See, this particular particle. It was moving in this direction, it went and it hit the wall of the container. This particle is also hitting the wall of the container. Similarly, this particle is hitting. So particles go and they colloid with the walls of the container and they bounce back. But the moment they colloid with the walls of the container, what happens? They apply some force on them, and due to application of some force with some speed on a specific area, these particles exert some pressure on the walls of the container. So, the gases exert pressure on the walls of the container because of collision of particles with some speed, with some force on a specific area. So, that is why gases exert pressure on the walls of the container, and the gases have a pressure due to the force exerted by the particles per unit area on the walls of the container. Okay, so yes, each and every gas exerts some pressure on the walls of the container in which it is kept. Now I am coming on to the temperature. What is meant by temperature? Temperature is the measure of degree of hotness or coldness of any body or environment. Whenever we have a look at the value of temperature of any environment or a body, it gives us an idea how much hot that body is or how much cold that body is. And there are three main scales on which temperature is measured. The first scale is Kelvin scale, the second scale is Celsius scale, and the third scale is Fahrenheit scale. Celsius will be studying about these three scales in detail, but yes, I want to tell you that Celsius scale of measuring temperature is the most commonly used scale. Okay, let's discuss about these three scales one by one in detail, and we'll also have a look at how we can convert temperature value from one scale to other scale, that is from one unit to other unit. Okay, starting with the Kelvin scale, which is also known as absolute scale. Okay, Kelvin scale is also known as absolute scale, and it is the SI unit for measuring the temperature. What is the SI unit? Kelvin is the SI unit. The abbreviation that we use is capital K. If I talk about the freezing point and boiling point of water on Kelvin scale, the freezing point of water on Kelvin scale is 273 kelvins and the boiling point of water on Kelvin scale is 373 kelvins. From here, you can easily relate. See, you might not be able to realize how much low temperature this 273 kelvins is. Let me tell you the value of 273 kelvins in degrees Celsius. You can even guess it yourself. 273 kelvins is the freezing point of water. You all already know the freezing point of water in Celsius scale. What is it? Yes, it is 0 degrees Celsius. So, 273 kelvins is equals to 0 degrees Celsius. So, this is the 273 kelvins is quite a low temperature, and 373 kelvins here is equal to 100 degrees Celsius. So, this is a quite high temperature, isn't it? So, just to give an idea to you all how much this 273 will feel like, 273 Kelvin will feel like, it will feel as 0 degrees Celsius because the value in degrees Celsius is 0 for 273 kelvins. Okay, so this is how, this is the freezing point of water and this is the boiling point of water on this particular scale of temperature. Coming on to the Celsius scale, as we have already discussed and I have told you that Celsius scale is more common for measuring temperature as compared to Kelvin scale. Although Kelvin scale is SI unit, Kelvin is the SI unit, but we commonly use the Celsius scale and we express the temperature in degrees Celsius, isn't it? And on this scale, the freezing point of water is 0 degrees Celsius and boiling point of water is 100 degrees Celsius. If I talk about how Celsius scale and Kelvin scale are related to each other, if we want to convert value of temperature from Kelvin scale to Celsius or from Celsius to Kelvin, what we do? See, temperature in Kelvin is equals to temperature in degrees Celsius plus 273. That means if they give you value of temperature in degrees Celsius, you simply need to add 273 to that value. You will get the value in kelvins. For example, I give you a value 10 degrees Celsius and I ask you to find out the value in kelvins. What will you do? To find out value in kelvins, you will add 273 to 10. So, 273 plus 10 will give you 283. So, 10 degrees Celsius is equals to 283 kelvins. If you want to do reverse of it, how will you do? If the value is given to you in kelvins and they ask you to give the value in degrees Celsius, how much 298 Kelvin will be in degrees Celsius if they ask you? What will you do? You will subtract 273 from this. So when you subtract 273 from 298, what you get? You get the value in degrees Celsius. And how much will it be? It will be 25 degrees Celsius. 298 kelvins is equals to 25 degrees Celsius. So this is how we can convert temperature from Celsius to kelvins and from kelvins to Celsius. Okay. Coming on to the next scale, that is the Fahrenheit scale. Fahrenheit scale is another common scale for measuring temperature, and the unit that we use, or say the abbreviation that we use, is degree Fahrenheit. This is the scale which is used in thermometers. You must have heard of body temperature as 98.6 degrees. Sometimes when we get fever, 99 it is, 100 it is, 101 it is. Is it in degrees Celsius? No. The values which thermometer gives us are actually in degree Fahrenheit. Okay. And on this particular scale, the freezing point of water is 32 degree Fahrenheit and the boiling point of water is 212 degree Fahrenheit. How the temperature in degree Celsius and degree Fahrenheit is related to each other? That means if we want to convert temperature from degree Celsius to Fahrenheit and from Fahrenheit to degree Celsius, we will use these two different formulas. Yes, you have to pay attention in this particular case that the formulas are a little different from each other. This first formula you will use when you want to change the temperature from degree Fahrenheit to degree Celsius. That means you should know the value in degree Fahrenheit and you want to find out the value in degree Celsius. At that time, you will use this formula which is written at first on the top. And this formula which is written below this one is used to convert temperature from degree Celsius to degree Fahrenheit. So you should be careful. There is not a single formula. There are two different formulas. When you want to convert temperature from Fahrenheit to degree Celsius, use this first formula here. And when you want to convert temperature from Celsius to Fahrenheit, use this second formula here. Okay. And while putting values and while solving, you need to strictly follow the board mass rule. Okay. So, in this particular case, what will you do? First of all, you will subtract 32 from the value in Fahrenheit because we solved the brackets first. Whatever value we get inside this bracket, then we'll open the bracket and then we'll multiply it with 5 by 9. So this is how it will go here. But in this particular case, you will not add 32 to degree Celsius. No. First of all, you will multiply the value in degree Celsius to 9 by 5. Whatever you get here, you will add 32 to it because we do multiplication in preference to addition according to board mass rule, isn't it? So, you have to be careful while solving the questions based on conversion of temperatures. And yes, I have got a few practice questions for every one of you. The first question here is conversion of temperature from degree Celsius to kelvins. To obtain the values in, it is from kelvins to degree Celsius. The values are given in kelvins and you have to find the value in degree Celsius. What will you do? What formula will you use? You will subtract 273 from these values which are given in kelvins to obtain the values in degree Celsius. Okay. So, I want you to do this question at home as homework. I have also included the solutions for your reference. But yes, try it yourself before you look at the answers. So, use this formula, subtract 273 from whatever values are given here in Kelvin. You will obtain the values in degree Celsius. Similarly, one more question. Here the values are given in degree Celsius and you have to find out the values in Kelvin. What will you do? You will add 273 to the temperatures which are given in degree Celsius to obtain the values in kelvins. Okay. So, again this question goes as homework. It is a practice question based on your understanding. You need to do this. Similarly, I am giving you two more questions where you are in need of using the formulas which relate temperature in degree Celsius with the temperature in Fahrenheit and convert the temperatures. In this first question, the values are given in degree Celsius. You need to find out the values in Fahrenheit. Which formula will you use? This particular formula you will use 9 by 5 multiplied with the temperature in degree Celsius plus 32. So please try to solve these questions at home, and in this question values are given in Fahrenheit and you need to find out the value in Celsius. So which formula will you use? You will use 5 by 9 and then inside the bracket you have temperature in Fahrenheit minus 32. So first of all you will solve the brackets and then multiply the obtained value with 5 by 9. Okay. Now again solutions are included for your reference. Now let's talk about the two newly discovered states of matter, the plasma state of matter and the Bose-Einstein condensate. Plasma state of matter is known as fourth state of matter, and this plasma was first of all described by Irving in 1920s. Yes, this person explained and described about plasma as fourth state of matter in 1920s. And if I talk technically about plasma state of matter, it is nothing but an ionized gas which consists of positive ions and free electrons. Now you might not be getting it, so let me explain you. See, we all know that when we add heat, when we heat a solid, it converts to liquid. When we heat a liquid, it converts to gaseous state. But what happens when we heat a gas to super high temperatures? The gas gets ionized. What is meant by ionized here? That means the gaseous atoms convert to positive ions by loss of electrons. You'll get to study about the structure of atoms in detail in the upcoming chapters in class 9th only, and at that time you will come to know that atom from inside is made up of electrons, protons and neutrons. These electron, protons and neutrons are known as subatomic particles, out of which electrons can be ejected out of atoms or they can be added to the atoms, and this is how ions are formed. We will be discussing about ion formation in the upcoming chapters in detail. For now, what you can understand that when we heat atoms of a gas to super high temperatures, the electrons are ejected out of those atoms and atoms become positively charged ions. Due to loss of electrons from atoms, atoms get converted to positive ions. All these red ones represent positive ions here. Okay, and the yellow ones with the negative sign represent electrons which are ejected out of these gaseous atoms. So, from inside, the plasma state consists of positively charged ions and negative electrons, but overall electrical neutrality is maintained. Yes, the total amount of positive charge is equal to total amount of negative charge. So, from inside, the plasma is ionized gas. It is obtained from the gaseous state. Now, if I talk about naturally occurring plasma, plasma occur in nature as well. Plasma is formed at the time of lightning. Air consists of gases. When electrical discharge takes place due to high amount of energy, the gases gets ionized and glowing plasma is created. Similarly, suns and stars also have glowing plasma inside them, and that is why they shine so bright. And from here we have understood that yes, plasma state of matter, it glows, and hence it is made use at a few places, especially in the field of marketing or when we are in need of giving signals. You must have seen this kind of open and close signs outside of the shops and restaurants, isn't it? So how these neon signals and fluorescent light bulbs work? See, inside the long glass tubes, in the structure of these signs and signals, what we fill a gas. As soon as light is turned on, electricity flows through the tube. The electricity here serves as a source of energy and charges up the gaseous particles. These gaseous particles undergo ionization and produce plasma. So, this charging and exciting of the atoms create glowing plasma inside the bulb, and we are able to see glow. Okay. Coming on to the Bose-Einstein condensate, which is considered as fifth state of matter. This particular state, or say Bose-Einstein condensate, was first of all predicted theoretically. Its prediction was made theoretically, not on the basis of any experiment, but yes, on the basis of theoretical studies. One of the Indian physicists predicted about Bose-Einstein condensate, and that Indian physicist is Satyendra Nath Bose. We call him S.N. Bose. So the word Bose here is from this person's name who theoretically predicted about Bose-Einstein condensate, and later on, based on the work of S.N. Bose, Albert Einstein described Bose-Einstein condensate as fifth state of matter. So the second word in its name, that is Einstein, comes from the name of the second scientist who contributed in its description as fifth state of matter. So Bose-Einstein condensate is considered as the fifth state of matter. Nothing much is known about Bose-Einstein condensate till now, but yes, I would like to give you small information about it. Bose-Einstein condensate is again obtained from a gas by cooling that gas at super low temperatures. And there is one requirement. The gas which you are trying to convert to Bose-Einstein condensate should have very, very low density. And such a gas, when super cooled, when it is cooled to super low temperatures, it gets converted to Bose-Einstein condensate. So this is all about the states of matter. Now I again have a few practice questions for every one of you. I want you all to try and write answers to all these questions based on your understanding from today's session. So there are 10 questions which I am again giving you as homework. Now let's quickly recap what we have discussed and understood in today's class. We discussed about the liquid state and gaseous state of matter in detail. At particle level, we understood their properties. We understood about the fluidity, rigidity, compressible and incompressible nature of all the states of matter. We discussed about the fourth and fifth state of matter, and we also discussed about various scales on which temperature can be measured and how we can convert temperature value from one scale to other scale. I hope every one of you properly understood everything in today's session. That is all from my side. Thank you.